FTP is commonly used for file transfers. In this section, I'm going to show you the basic FTP packet structure. In the next section, we'll go on to filtering FTP traffic, capture filters, display filters, and individual field filters. And then finally, we'll go to normal and abnormal FTP communications. The trace file that I have open right now is called ftp-port-ok. And we can see at the beginning of this trace, we have an ARP query. So someone is trying to find, most likely, the router to get off of the network. Then we have a DNS query looking for www.packet-level.net. They get a response back, and here we see the three-way handshake. Now, FTP by default uses port 21, but it doesn't have to. Someone can easily set up an FTP server to use a non-standard port. This is the command port. When data is exchanged, it's exchanged over a different port. A lot of people typically assume that the data is exchanged over port 20, but in actuality, it's typically done over dynamic port numbers. So this is the three-way handshake, and immediately after the three-way handshake, here we see the banner coming back from the server. At this point, I'm going to move this window up, and we'll focus on the contents of the FTP portion of the packet. So this is a banner, and in FTP communications, there are numerical codes that the server can send back to the client indicating how successful or unsuccessful the client request was. In this case, it's an unsolicited request. It's an unsolicited reply, and we have the server sending out the banner with a 220 in front of it. Let me show you where you can find all the numerical codes for FTP. The numerical codes can be found inside the RFC. FTP is covered by RFC 959, and I'm out on the IETF website. If you want to go directly to an RFC, all you have to do is go to www.ietf.org/RFC/ and then the number of the RFC, making sure that the digits here equal up to 4 digits, so we have to pad it with a 0 in front, .txt. Here you can see the reply codes. There's a 220. These codes are the basic code set by function group, and if we scroll down, you'll see the entire list after this. There's our 220, service ready for a new user. And right after that, we can see that our server sends the banner across to the user. So that's one file format. I'll scroll down to packet number 10, and in packet number 10, we have a command being sent across the cable. Now, the commands sit immediately following the TCP header. So I'll view the packet bytes, and here we could see the TCP header, where the TCP header ends right here. It's offset 3.5, and at offset 3.6, that's where our FTP commands begin. You can see down in the lower left-hand corner the syntax for the display filter for an FTP command, and we'll be working with that in the next section. So this is a normal FTP communication where we have a command from a user or a numerical value here from a server. FTP data transfer packets are a little different. Here we can see the user logs in, username anonymous, password telegraph, misspelled 23, and a little further we see another connection opening. Now this connection is for data transfer. I'll right mouse click and follow that stream, just to filter that data transfer stream out easily. I'll close that window, and now I'm looking at the first communications that go across the cabling in this data transfer. Here we have the TCP header, and then the FTP data follows immediately after the TCP header. We don't need any additional header information at all. In the next section, we'll look at how to filter on FTP traffic. Capture filters, display filters, and then individual field filters. In this section, we're going to start out by looking at capture filters, and then I'll move on to the general display filter for FTP traffic, and then finally we will end up with building filters based on individual commands or response codes in FTP packets. I'll click on the Capture Filter Options window to open this up, make sure I don't have any filters existing. Then I'll go to the Capture Filters window itself, and I'm just looking to see if Wireshark came with any FTP filters, and it does not. So I will create a brand new filter called FTP, and the filter string will be TCP port, and I can type in FTP because Wireshark recognizes FTP indicating port 21. Now, if you have FTP communications running over a different port, a non-standard port, this capture filter won't work. So you need to be aware of that. If you know that somebody is running FTP over port 24, you're going to need to place that in there instead. So I'll just leave it as FTP, click OK, and start capturing. Now in the background, I'm going to generate some FTP traffic. Now I just paused for a moment so I could generate some traffic in the background, and we can see that we have a FTP communication. We see the three-way handshake that occurs at the beginning, and then we see the server coming back saying ready for a new user. That's what 220 indicates. And there's the user command, anonymous. The server responds with a numerical code 331 saying that the password is required for anonymous, and the password that was given was IEuser@. This is just because I did this inside of Internet Explorer. Server came back and said, I'm sorry, that's not correct, and the connection was closed. At this time, I tried to make another connection, again with anonymous. Again, it said incorrect, I will not accept that. Then I tried to make another connection with the user Yoda. It said passwords required for Yoda, and I gave a password of blah blah. It said, I'm sorry, that's not correct either. So that's an example of how you can quickly build a capture filter for FTP traffic. I'm going to stop capturing and save this trace. I'm going to save this trace as ftp test.pcap, and we may come back to that later. Now I want to show you how you build a display filter for FTP traffic, and then we'll come back to building filters for specific numerical codes and specific commands in FTP communications. I'm going to open up a trace file called FTP just an example, and I just created that in the background. Here we have a lot of different traffic, and we can go into statistics protocol hierarchy to see what this traffic is. So over UDP, we have some DHCP communications, we have some messenger communications, and there's some FTP traffic in there. I want to pull out all the FTP traffic, so I'll build a display filter that's just FTP, that's it. Hit enter, and there it pulls out the FTP traffic. Now, although it pulled out the FTP traffic, you'll notice that I don't have things such as the handshake process and the acts that took place. So if I wanted to, I could type in tcp.port =21. Now notice I'm not putting a source port or destination port. I'm just saying either source or destination should be port 21. And I'll apply that filter, and now I can see all of the handshake packets and the ACK packets and the FIN packets that are part of the FTP communications. It's very easy to build filters based on specific fields in an FTP communication as well. So I'll select this packet that has the pass command in it. There's the request command. Now, I've right mouse clicked and expanded the subtrees on the pass level, or you can right mouse click where you see file transfer protocol. Right mouse click and say expand subtrees. It'll break this down for you. Then I can click on the request command line, right mouse click, prepare a filter based on the selected value, and you can see the syntax. And once you recognize that syntax, you can copy that. So I'm going to look for any packets that have the pass command or the user command. And it is case sensitive. So if a packet matches this side of the filter or this side of the filter, it will be displayed. And I'll apply that, and now I have a nice listing of all the usernames and passwords that somebody tried when they talked to that FTP server. We can do the same thing with the numerical codes. I'll clear out that filter. Here we see a response code of 530. Because I've expanded it out, there's my line where the response code sits. I'll right mouse click, prepare a filter based on the selected value. There it is up above, and I'll apply it. And I can see that I have 3 login incorrect response codes. Obviously, that's something you don't want to see too often on your network because that would indicate someone is trying to get into an FTP server and they don't have the correct login information. Might be somebody trying to password crack on an FTP server. You can get the display filter syntax over at the Wireshark webpage by going to Documentation, the complete list of display filters, clicking on the letter F on the index line, and selecting FTP. You can scroll down, you can see the FTP fields when we're in active mode or passive mode, and we'll talk about that in the next section. And there are our response codes, and there are our request commands. Inside of Wireshark, you can also use the expressions area to define filters for FTP traffic. We click on the expressions button. Now remember, if you go to the expressions button and you have something sitting in the background, it will append it to the information sitting in the background. So you may want to clean that out first and then come over into the expressions area. I'll type FTP, open this up, and here we can see there are the individual filters that we can build for FTP communications. In addition, we have another filter just called FTP data. FTP data is present, or FTP data contains. Let's try out the FTP data filter. I'm going to cancel this out, and I'm going to open up a trace file called FTP port OK. Now I'm going to try to build an FTP data filter using expressions. I'll click on the expressions button, and I'll type in FTP, and there's the FTP data is present. Click OK, apply it, and now I'm only looking at the FTP data that was transferred across the cabling system. I can right mouse click and follow that stream to see it all on one screen. And it wasn't a very interesting data file. Needless to say, this data file just has the number 10K, 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 10K all the way through it. I'll close this window. And now I want to show you how you can filter out an FTP data stream and reconstruct the data that crossed that FTP data stream. I'll hit clear. I'm going to open up a trace file called FTP download good. Here we can see an FTP communication, and the file looks like it's in a directory called Fun with Bill, Microsoft 1978.jpg. There's the user asking to retrieve the file, and there's the FTP data stream. I'm going to right mouse click on the FTP data stream, and I'm going to follow that stream. There's the file being downloaded, and there's no header information at all, no command information to get in the way when we're looking at the FTP streams that have been transferred. First, I'm going to make sure I click raw, because I don't want any special characters saved with this. So I want to make sure I always click raw first when I'm going to try to reconstruct a stream. Say save as, and I'm going to call this sample. Now we know that it ends in JPG because we saw that in the request line. Also, this is a file signature for JPG traffic, for JPEG traffic. I'll say save. And now I want to go out and see that file. I'm in my tracefileall directory where I saved that file. There it is, sample.jpg. I'll double click on it, and that's the file that was transferred during that FTP session. I'll close this window down and go back to Wireshark. Any file that is transferred using standard FTP can be reconstructed. All you need to do is get the stream content of the data communications, the data channel, and make sure that you go into raw mode and then save as. If you don't know the extension, you're not sure because you didn't see the name of the file anywhere in your trace, you missed that part, always look at the beginning of the file for some sort of an indicator as to what type of file it is. For example, a PDF file will start with %PDF. So you can see it's pretty easy to make filters for FTP communications, and it's very interesting when you begin to reassemble the FTP data that's across the cabling system. Now we're going to look a little further into FTP, into the standard behavior of FTP when it's in either active mode or passive mode. The trace file I have open right now is called ftp-port-ok, and this is an active mode file transfer. The active mode file transfer process uses the port command. So here we can see the three-way handshake, and we see the server come back with the banner. Now I'm going to get rid of the packet bytes window because we don't really need that. And the user logs in as anonymous with a password of this funky telegraph something. Everything seems to go well, and then the user, when we get to packet number 18, the user sends across the port command. And in the port command, there's the packet right there. If we look at Wireshark's detailed decode window, you can see that it's interpreted this command for us. Now, in this scenario, the user is this 192.168.1.100 device, and the server is the 128.121.70.151 device. So the user is sending the port command to the server, and in the port command, the user is saying, this is the port that I'm going to open for a secondary data transfer connection. We see the port command. We see the argument go across in this strange format here. This format translates to the IP address in the beginning, and the last two pieces there, 4,10, translate to the active port number that the user is telling the server about. We see the server acknowledge receipt of that and say that the port command has been successful. The user says, I want to do a directory listing and list. Server says, OK. And now we can see that there's a connection coming from the server to the user, the SYN, ACK, and it's hitting the user on port 1034, the port that the user said was open for the data transfer. We are going back and forth now between the command channel and the data transfer channel. Here is a packet that is in the data transfer channel, and then this packet right here, packet number 26, is in the command channel. And now we can see the data being transferred. We can see that another port command has been sent across from the client saying, I want to open up a secondary channel, and this is the port that I want to use, 1035. Server says that's okay, and the client makes the request over the command channel to get the file called 10k.html. The server opens up that secondary connection and then begins the transfer of data. So this is considered an active FTP file transfer because we use the port command. Now some people don't like that because our user, when sending the port command information across the wire, could put in somebody else's IP address and someone else's port number. And then the server is going to make a connection to that other system and download the file to another system. So there are always concerns about that. I'm going to open up another trace file, and this one is called FTP download good. And in this case, we see a passive file transfer taking place. In this case, the file transfer will use passive mode. So in this case, we have the user at 67.180.70.76 requesting to go into binary mode. They're sending the type I command. And before we go into passive, let me show you where the list is for all of the command types. All of the commands that are used in FTP are listed in RFC 959 in section 4.1.3. As we scroll through here, you'll see there's the retrieve command, there's the store command. Even though you might say get or put, on the cabling system, FTP would use retrieve and store. There we see the delete command, the remove directory command, RMD, the make directory command. You're going to see the make directory command when we look at unusual FTP communications in the next section. There's the list command, print working directory when you do something that requires that you see what directory we are in. There's our nlist, the name list. This is a directory listing as well. So all of them are contained in section 4.1.3 of the RFC. Now back in my trace file, the user sends a request, a passive request to the server. And the server responds by saying, okay, that's all right with me. I'm going to enter passive mode. And at this point, when we look down into the detail window, we can see the server saying, I'm entering passive mode and giving a string of numbers. And just as in active mode when we send the port command across, this has an IP address and a port number. In this case, the server is saying, listen, I'm opening up a secondary connection. I'll allow opening a secondary connection. There's the server's IP address, and this is the passive port that the server will be listening on. Right after this, we can see that the client makes a connection to the server on that port. So there's the three-way handshake on the secondary port. Then we're back into the command channel, and then we're back in the data channel after that. So those are the two common ways you'll see file transfers taking place. And a lot of people don't like active FTP. They don't like the users saying, okay, turn around and connect to me, because they might send the server somewhere else. But I'll show you in the next section some problems with FTP communications, including times when the attempt to use a passive connection failed, or when the attempt to use an active connection failed. The first unusual trace file that I'm going to open up is called FTP-passive-fail. FTP-PASV-fail. In this case, we see a query, somebody going out to ftp.novell.com, response coming back, handshake being accepted. We can see the user trying to log in as anonymous, and at this time that FTP server would allow a guest login. The user sent pass Mozilla at, which was just because they were doing this from inside of a browser. There's the banner coming down, various commands, and at this point the client in this communication says, I want you to open up a passive connection for me. I want you to set up a port for me to use. The server responds by saying, okay, I've set up this port number 22807, and this is the IP address. Then we see the client make a handshake to that port, 22807. But there's no response. The server never sends back a SYN-ACK. And the client tries again, and again, and again, and finally the client on the command channel decides to just give up. And on the command channel, the client sends a FIN-ACK saying, I'm out of here. And look at the response from the server. The server turns around and says, you know, you could at least say goodbye, which is pretty funny. But the client's giving up because it knows that it can't do any data transfer at all. So why even hang out on that server? There we can see the last attempts at making a handshake to that server. We can right mouse click on that failed communication and say that we want to follow the stream. We know there's no data transferred, but it will just quickly bring up the attempts. These are all the attempts that the client made to connect to port 22807, all of which were unsuccessful. The next trace I'm going to open up is one where a server, an FTP server, has some security settings built in, and it doesn't like what the client is doing, and it says so in plain text on the cabling system. This trace file is called ftp-fxp-cutoff.pcap. Now I'm going to clear out my previous filter so I can see all of the traffic. I'll just start by looking at packet number 5 in this trace file, where we have the handshake taking place. The client in this case is this 204 IP address, and the server is the 24 address. So we see a handshake works great. The server turns around and gives the client the banner. The client receives the banner information fine. The server then says, please enter your username. The client enters the username. username's okay, and then the password. Now I've put in fake usernames and passwords. I've edited this trace file using just a simple hex editor, and that's why you may see, if you're doing colorization, that in the TCP header the checksum is invalid, and that's because I just went in and did a quick little edit on it. So after the password is accepted, the user's logged in, client says print working directory, moves on, and now the client says, I want to make a secondary connection, so I want you to go into passive mode. The server responds by saying that it is going into passive mode, and there's the server's port that it's going to open up. It tells the client, you can make a connection on this port for communication. The client says send SNAC ACK, makes a perfect connection on that communication, and then sends a list to get the directory contents from the server. In packet number 27, the server responds by saying that it's opening up a data mode connection for 0 bytes. So nothing's really going to transfer down to the client from there because there's nothing in that directory. And then the server and the client finish up that communication. Now, the next thing that happens is the server responds by saying data transfer was successful. And that's all taking place on this port 1302. The data transfer takes place on 1302. This response comes from the command channel. Client acknowledges receipt of that. At this point, the client says, I want to set up for a binary file transfer. Server says, great. Client says, I want you to set up another port for me. The server comes back and says, great, now you can make a connection to 1303. At this point, the client does a perfect handshake to 1303, and then through the command channel says, I would like to store a file called indesigntemplate.indd. The server responds and says, I accept that, great, got that packet. Client says, and then the server says, great, I'm opening up binary mode communication data connection for InDesign. And at this point, the server turns around and says, oh, wait a minute, I changed my mind. So it sends a FIN ACK across from port 1303, the one that we're supposed to be doing the upload from the client to the server on. And it responds with a 425 error saying that, I'm sorry, I can't open that data connection because this could be a possible bounce attack or an FXP transfer, and you've been kicked. So it shuts down that connection. It doesn't like the idea that the client is going to store data on that server using the passive mode setting there, because the server doesn't like the upload process being set up in passive mode. It wants it to be in active mode only. That's the way that server was configured. So in that case, the client had to be reconfigured to go back and ask in active mode, not passive mode. Here we can see the process of shutting down this connection. To say the least, the client is a little slow on getting it here. So the server has sent back a message saying, no, I'm going to shut this down. I can't get that connection to stay open. And the client begins to send the data across the wire. So here we see actually 512 bytes of data going across the wire, and the server sends a reset back to the client. The client is still sending data, another 512 bytes. While the server says, shut up, the client says, here's some more, shut up, here's some more, shut up. Finally, we get the client turning around and sending an acknowledgement of receipt for one of these packets, and the server still sends a reset, and the client accepts acknowledgement at that point and says, okay, all right, fine, I see that it's shut down. So it's a long process that the client went through to kind of figure out what was going on, but in time it was really nothing. Here you can see the time column. But if you have an FTP client software package that doesn't provide those types of error messages back to you, you can always look on the cabling system and see what it says is actually going on. The next trace file I'm going to open is called FTP write check, ftp-writecheck.pcap. Now again, in this trace file, I've gone through to edit the packets that have usernames and passwords in it. I just kind of do that as a general rule when I save the trace files for FTP communications or any communication that has clear text passwords. I'll turn off the colorization because it looks really, really ugly in here. So here we have a DNS query and the DNS response going to www.packet-level.net. We see the three-way handshake. Don't pay attention to that source name for the port number. It just happens that the client chose port 1434 as the dynamic port to connect to the server. That port is also associated with Microsoft SQL Server port. Server comes back and says, great, I'm an FTP service. We see the username, we see the password go through, everything seems to be fine. And this is all done transparently by the application that was running on this client system. And the user never sent anything across the wire other than setting up the application with the username and password, so that when the application wanted to send the data up to that server, the user could just click a button and it would just go up to the server. But this was interesting to see in the background. We have the application saying, what's the directory I'm in? Well, you're in the root. And then the application tries to make a directory called XYIZNWSK. The server responds by saying, hey, this file exists, so I can't create it. So the application said, well, remove it then. And the server said, okay, I've removed it. And then the client application says, now make it again. And the server turns around and says, okay, that directory was successfully created. Now this whole process right here, once I talk to the application developer, it's a write check. They want to make sure that before they try to go through the process of writing, they do this little test at the beginning to see if they can write to the server. But it looks really strange on the cabling system. And if you don't expect an application to send the request to make a directory, just like you don't expect it to send a store command, this is something that you want to look for on the wire to check and see if there's any of these rogue make directory, remove directory, or store or retrieve commands crossing the cabling system. The last FTP trace I'm going to open up is called FTP crack. In this case, we have someone running a password cracking routine against an FTP server. Actually, they're running it against a honeypot, a system that was set up as a honeypot. We can see that we have a three-way handshake, and we already have a response saying, I'm sorry, the login's incorrect. So let's go down to where the server comes back and says a password is required for the admin account. Now this I just sort of grabbed in the stream as I noticed that someone was doing password cracking on that box. We can see the pass that they sent in, Merlin. Server said, I'm sorry, that's not correct. Please tell me the password. Well, how about Mercury? I'm sorry, that's not correct. Please tell me a password. And we can see that this is a multi-threaded password cracking application, because it has multiple different attempts going on simultaneously. We can go up under Statistics and Conversations and see how many different connections were set up for the password cracking routines. 714 in this trace file. These are all to the FTP port 21. I'm going to close this, and I'd like to know a little bit more about the person that's running this password cracking routine. I'd like to try to figure out maybe what dictionary they might be using. So I'm going to select one of the files, one of the packets that has the pass command in it. I'll right mouse click and apply this as a filter. Now I'll be able to pull up the whole entire list of the passwords that they're trying. And I can see that they're doing alphabetical listing, and this isn't a very long password list because they're already, they should have a lot more in the S's, things like that. But they loop back around. So notice that once they finish going through the letter Z, then they loop back around to A, then they're on B, C, D, E. And here we could see just retransmissions on the cabling system. These are just retransmissions of the pass command being sent across the cabling system with the passwords. That certainly is something that you don't ever want to see on the cabling system, and you want to track that in the world of FTP communications.